factoring the sum and difference of perfect cubes. Well, before we start talking about how to factor the sum and difference of perfect cubes, let's talk about what a perfect cube is. What are numbers that are considered to be perfect cubes? Well, a perfect cube would be a number that we can get by multiplying another number times itself 3 times. So, for example, a number that would be a perfect cube would be 8, because if we multiply 2 times 2 times 2, we get 8. Or 1 would be a perfect cube, because if I multiply 1 times 1 times 1, I get 1. So let's list the first 10 perfect cube numbers. All right, the first number that is a perfect cube would be 1, because like I just said, 1 times 1 times 1 is 1. 2, if I multiply it times itself 3 times, I get 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And 10 cubed is 1,000. Alright, so those are the first 10 perfect cubes. Now for variables that are perfect cubes, how do we get those? Just like numbers. If I can multiply a variable times itself 3 times to get that variable, then it is considered to be a perfect cube. So x times x times x would be x cubed. So x cubed is a perfect cube. X squared 3 times would give me x to the 6th. So x to the 6th is a perfect cube. X cubed 3 times would be x to the 9th. So that is a perfect cube. So what do you notice about all of these variables that are perfect cubes? All of their exponents are divisible by 3. So if a variable has an exponent that's divisible by 3, then it is a perfect cube. So in order to factor a perfect cube, we have to have a binomial that contains variables and numbers that are perfect cubes. Now, unlike the difference of perfect squares rule, for the cubes, it can be plus or minus, a sum or difference. Excuse me. So this is the rule for factoring a perfect cube. This is what it would look like: a perfect cube plus a perfect cube, or a perfect cube minus a perfect cube. Now, if you'll notice, the answer is a binomial times a trinomial. That's what it will look like. Now, the thing you need to get from this rule is, if it's a sum of perfect cubes, if this is plus, then the pattern in our answer is plus, minus, plus. So if it starts with a plus, the answer is plus, minus, plus. If it starts with a minus, the pattern is minus, plus, plus. If it starts with a minus, the pattern is minus, plus, plus. So you just kind of have to commit that to memory. So now let's factor a perfect cube. For number 1, we can see that the variable is a perfect cube because the exponent is divisible by 3, and we know that 8 is a perfect cube. So this is how we start our factoring. Like we said, the answer is going to be a binomial times a trinomial. So we're going to create the binomial by taking the cube root of each term. The cube root of x cubed is x. The cube root of 8 is 2. Now we need to remember the pattern. If it starts with a plus, the pattern is plus, minus, plus. All right, that's going to be in our trinomial. Once we get to this part, we don't look at what we started with anymore. We're only going to look at what we just created. So we take our first term and we square it. If I take x and I square it, I get x squared. Then I multiply these two terms together. X times 2 would be 2x. Then I take the last term and square it. 2 squared is 4. And now I'm done. This whole thing, this binomial times this trinomial, is my answer. Okay, let's try it in number 2. Again, we have the same numbers, but this time it's a minus sign in between. We take the cube root of the first term. The cube root of x cubed is x. The cube root of the last term, the cube root of 8, is 2. But if the sign in the middle is minus, my pattern is minus, plus, plus. Alright, so then I don't look at this anymore. I take what I just wrote. I take the first term and square it. If I square x, I get x squared. Multiply the two terms together. X times 2 is 2x. Take the last term and square it. 2 squared is 4. And that's it. That's my answer. Okay, for number 3, is 64 a perfect square? It's not a perfect square, a perfect cube. Yes, it is. A cubed is also a perfect cube, and 1 is a perfect cube. So we know we can use this rule. So I'm going to take the cube root of each part. The cube root of 64 is 4. The cube root of a cubed is a. And the cube root of 1 is 1. And this starts with a plus, so my pattern is, if it starts with a plus, then the pattern is plus, minus, plus. Okay, now I don't look at this anymore. I take this, the first term, and I square it. If I square 4a, I get 16a squared. Multiply these two together. 4a times 1 is 4a. Take the last term and square it. 1 squared is 1. And that's my answer. Alright, number 4. Let's go through those steps again. Take the first term, take the cube root of the first term. The cube root of 64a cubed would be 4a. Take the cube root of the last term. The cube root of 1 is 1. This is minus, so my pattern's going to be minus, plus, plus. Alright, take the first term and square it. That gives me 16a squared. Multiply the two together, that gives me 4a. Take the last term and square it, and I get 1. And that's my answer. Alright, for number 5. First of all, these are not perfect cubes, so let's see if there's a greatest common factor. Well, I know that they're both divisible by 2. So if I divide 16 by 2, or if I factor out a 2, I'm left with 8r cubed. And then 54 divided by 2 would be 27. Now I have perfect cubes. So again, anytime I factor out a greatest common factor, make sure that we bring that along with our answer. Okay, and then I'm just going to take this and factor it using a difference of perfect cubes. Alright, so the cube root of 8r cubed would be 2r. The cube root of 27 is 3. If I start with a minus, my pattern is minus, plus, plus. Alright, take this first term and square it. 2r squared would be 4r squared. Multiply the two terms together and I would get 6r. Take the last term and square it. 3 squared is 9. And then this whole thing along with that 2 on the front is my answer. So just be careful to know the difference between factoring perfect squares and perfect cubes. They both start out as binomials, but if it's perfect squares, it has to be minus in between. If it's perfect cubes, it can be plus or minus, and then they have different rules that we have to follow.